Welcome back to Collapsed Latents, this week in AI, where we cut through the noise and bring you the most groundbreaking AI advances of the week. Today, we're diving into a massive spread of research, from agents that can actually control your phone to video models that think like cinematographers. We'll look at OCR that exposes the blind spots of global scripts, quantum reasoning that's still struggling with the rules, and factory AI that finally understands engineering. Let's get into it. First up, let's talk about the holy grail of automation, GUI agents. The idea is simple. If an AI can look at your screen and tap, swipe, and type like a human, it can control any app without needing a dedicated API. But building a reliable agent isn't just about a better model. It's about the entire infrastructure, training, evaluation, and deployment. That's where ClawGUI comes in. ClawGUI is a unified, open-source framework consisting of three core components. First, there's ClawGUI RL, a reinforcement learning engine that trains agents on both physical Android devices and Docker-based emulators. To prevent training halts, it uses a spare server rotation system. If an emulator crashes, it instantly swaps in a fresh one. But the real technical breakthrough here is the use of dense, step-level rewards. Most RL models rely on binary rewards. They only know if they succeeded or failed after a long sequence of actions. ClawGUI implements a process reward model that analyzes before and after screenshots to judge every single step, providing real-time feedback. When combined with the GGPO algorithm, success rates on the mobile world benchmark jumped from 14.5% to 17.1%. They also address the reproducibility crisis in AI research. Often, papers claim marginal improvements that can't be replicated because of tiny variations in image resolution or prompt formatting. ClawGUI Eval solves this with a strict three-stage pipeline: inference, judging, and metrics. This allows researchers to rejudge old predictions without rerunning the entire inference process, achieving a 95.8% reproduction rate. Finally, there's the ClawGUI agent, a hybrid system that uses CLI for speed and GUI when necessary. It utilizes vector memories to remember your habits, like favorite apps and contacts, and can be controlled via Telegram, Slack, or Discord. The most impressive part: a 2 billion parameter model trained in this pipeline outperformed giants like QN3VL32B and UI Venus 72B. It proves that the future of agents isn't just about bigger models, it's about better systems. Moving from agents to aesthetics, video generation is finally stepping out of the uncanny valley. Most models can create a moving image, but few create a scene that feels real. Seedance 2 changes this by moving toward a native multi-modal framework. Instead of treating video as a sequence of frames, Seedance 2 treats text, image, audio, and video as equal inputs. This allows for cinematographic reasoning. The model actually understands the 180-degree rule, avoids axis crossing, and plans transitions like a professional editor. The audio is equally impressive. It doesn't just slap a soundtrack on a clip. It generates binaural, multi-track audio, ambient sounds, music, and narration, all perfectly synced. It even handles complex linguistic nuances, like traditional Chinese opera and specific dialects, with high accuracy. To prove it, the team built Seed Video Bench 2. Seedance 2 now ranks #1 on Arena AI leaderboards for both text-to-video and image-to-video, being the only model to exceed 83% usability across all dimensions. While it still has some quirks, like occasional multi-subject drift or lip-sync errors in crowded scenes, it handles 20 out of 22 possible input modalities. We're looking at a future where expensive VFX pipelines could be replaced by a model that understands the physics and art of cinema. Now let's shift to a more sobering topic: a quiet crisis in OCR. Most of us think AI can read everything, but the truth is that OCR is blind to a huge portion of human writing. We've spent years training models on high-resource scripts like Latin, Chinese, and Japanese. But the Unicode standard encodes 172 different scripts. To test this, researchers introduced GLOT OCR Bench, a massive benchmark spanning 158 Unicode scripts, including degraded, aged documents with ink spread and geometric distortions. The results were devastating. While models hit over 75% accuracy on Latin text, performance collapsed on low-resource scripts, which make up 94% of the benchmark. The best model, Gemini 3.1 Flashlight, scored just 7.7%. Most others were below 1%. Even worse is the hallucination problem. When these models encounter a script they don't recognize, they don't admit defeat. They guess. A Gujarati image might be output as Devanagari. Ogham script is almost always guessed as Latin. The researchers tried script-aware hinting, telling the model which language it was looking at, but it only improved accuracy by 0.7%. This proves the bottleneck isn't the prompt. It's a total lack of visual recognition for these scripts. It's a wake-up call. If we want truly global AI, we cannot ignore the 94% of human writing that has been left behind. GLOT OCR Bench is now open source on Hugging Face as a challenge to the community to fix this. From linguistics, let's move to the cutting edge of physics, quantum mechanics. Can LLMs actually reason through quantum problems, or are they just repeating code they've seen in training sets? Quan Bench Plus, a new benchmark from ICLR 2026, attempts to answer this. In classical coding, correct means passing a unit test. But quantum outputs are probabilistic. To solve this, Quan Bench Plus uses executable functional tests that measure the KL divergence between the model's output distribution and the canonical one. If the divergence is below 0.05, it's considered correct. The researchers used multi-framework alignment, implementing 42 tasks across Qiskit, Cirque, and Penny Lane. This allows them to distinguish between a model that fails because it doesn't understand quantum logic and one that just doesn't know the specific library syntax. The data shows a stark asymmetry. Models are best with Qiskit, hitting nearly 60% pass at 1, while Penny Lane lags at 43%. This suggests that performance is tied more to training data volume than to an actual understanding of quantum mechanics. Interestingly, they found that a feedback-based repair loop, where the model is given the error trace and asked to fix its code, boosted success rates from 59.5% to over 83% in Qiskit. But there's a catch: feedback fixes syntax, not semantics. The remaining errors are deep logic failures. LLMs can be coached to write syntactically correct quantum code, but they still can't think like a quantum physicist. Finally, let's look at AI in the physical world, specifically the factory floor. Robots are fast, but they often lack the precision to see the details that matter to an engineer, like the exact size of a screw or a subtle taper in a connector. Forge is a new benchmark and dataset designed to fix this. It combines high-resolution images with 3D point clouds, thousands of X, Y, and Z coordinates that map an object's geometry in space. When testing 18 top models on tasks like workpiece verification and assembly inspection, the researchers found that the AI wasn't bad at seeing, it was bad at understanding. A model could locate a part perfectly, but couldn't tell the difference between an M10 and an M20 bolt because it lacked the engineering logic. To solve this, they introduced reference conditioning, giving the model a gold standard image to compare against. This allowed the AI to spot the difference between a solid washer and a split spring. The real breakthrough, however, was the integration of 3D point clouds. By analyzing the span of coordinates, the AI could calculate exact dimensions, detecting parts that were slightly out of spec, things a 2D camera simply cannot see. The result: a small, compact model trained specifically on Forge saw accuracy jump by over 90% in some tasks, performing on par with models 78 times its size. It's a clear signal. We don't need bigger models for the real world. We need better domain-specific training. So what's the big picture this week? We're seeing a shift from raw capability to context. ClawGUI shows that infrastructure is the new frontier. Seedance 2 proves that realism is about physics and timing, not just pixels. Glot OCR Bench forces us to confront the fact that AI is still deeply biased toward the familiar. Quan Bench Plus reveals that models are still simulating reasoning rather than actually performing it. And Forge teaches us that understanding beats perception in the physical world. The future isn't about more data or larger parameter counts. It's about better alignment between AI and the physical world, between AI and human knowledge, and between AI and global diversity. If you're building or researching, the goal is clear. Build systems that see the world as it actually is, not just as we've trained them to see it. I'm your host, and you've been watching Collapsed Latents, This Week in AI. I'll see you next time.